Ladies and gentlemen, can I please have your attention?
Okay, so that's a bonded neutral generator, but the 220 side is not GFCI, so we can plug it in just fine. Got the drop cord hooked up into the outlet, into the house. Power to the house is off. We got our generator on. And we got power. Easy as that.
What you're about to see is nothing that you should ever try doing yourself. I repeat, do not try any of the harebrained things I do.
Alright, so today we're going to be hooking up this Ryobi generator into the house. We're going to put a plug there and do a whole home power system off of this.
Today I'd like to talk to you about an issue that keeps on coming up, and there's a lot of misconception about it, and it has to do with floating and bonded neutrals. What you'll find is people will be thinking that, a floating neutral is better than a bonded neutral, or so on and so forth, and I can't do this or I can't use it with a switch. And I mean, the truth of the matter is, if you have a bonded neutral generator, it will work with any switch out there. The issue that you run into is with the GFCI protection. So, for example, with this XP8000, it's a professional generator. If you look down below, it says a full GFCI protected panel for OSHA and NEC codes. So what they're saying is that this entire panel, including this 30 amp outlet, is protected by GFCI. Now, where that poses the issue is when you're trying to use this with a regular transfer switch, or I should say a manual transfer switch. When you flip that switch, it sees too many grounds for your neutral, because there's a neutral grounded in the switch and there's also one on the generator itself. So it trips breakers. What they make is these GFCI compatible panels. Now, this panel will work just fine because it is a 3-pole switch. So it is actually breaking the neutral when you're transferring power. Otherwise, if you use this with any regular type switch, you will trip breakers. Now, if you unbonded the neutral, so it would be a floating neutral, you would not have this issue. But it's a lot more than just disconnecting a ground wire or something along those lines. A lot of these have the grounding through the panel itself. So it's not just a simple remove this wire type deal. If you have any regular generator, whether it's a floating or a bonded neutral, you should have no issue with any switch unless you have a full GFCI protected generator.
First thing, you need to size your generator for your house. Second thing you need to look at is whether or not the generator is bonded neutral or floating neutral. Easiest way to tell, look right here. So this is neutral bonded to frame. Ideally, you want a generator that's floating neutral whenever you're doing a whole home hookup. But a bonded neutral will work as long as the 220 side, this side, the plug, this is right there, 240, 30 amp. As long as the 220 side that you're coming off of is not GFCI protected. These two are GFCI protected, it even says so right here. You can do a floating or a bonded neutral generator to a whole home hookup to the panel as long as the 220 side is not GFCI. Ideally, you want a generator that's floating neutral whenever you're doing this. That way you don't have to worry about it. Everything's going to work. But if you get a generator and the 220 side is bonded to the frame, then it's going to trip the GFCI breaker. This generator is not GFCI protected on the 220 side. So there's our plug. The little hooked section right there is our ground. Here's our neutral, and there's your 2 legs of hot. Now, if you can't find where your generator is bonded, neutral, or floating, you can just simply check it right here at the plug. It's very easy. It's got a simple voltmeter from Harbor Freight, and it's on continuity right here. It tests to see if there's a complete path through the wire. So, give you an example. See OL, whenever I touch them, it goes to 0. That means those both leads go to the same place. So what we're going to do to see if you can't find whether or not it's floating or neutral bonded, stick one end in the ground and one end in the neutral and if it goes to 0 on my voltmeter, it means this is a bonded generator. You can see it went to 0 right there. The bottom one's where I got the black pin in is the ground, where the red pin in is the neutral. So you can see right there it goes to 0. That means the ground and neutral are tied together, which means it's bonded. Now you can use a bonded or a floating ground generator with a home hookup, no problem, as long as the bonded generator, as long as the 220 side is not GFCI protected. If your 220 side where your big plug's going into your house, if it's GFCI protected and it's bonded, every time you plug it in to your house, it's going to trip the breaker on your generator. So keep that in mind. All right, here's everything else you need. Here's the outdoor box. It's the weatherproof. This is the Nema L1430, which means 30 amp, going on the side of the house. You need a drop cord that runs from your generator to the plug. And this plug, I ain't a fan of it. This is homemade. It works just fine, but the link I'll put in, it comes with the plug and the box together. But if you're wiring it up yourself, you can just get your cable. And for 30 amps, you're going to be looking at 10 gauge wire. And then you can just buy these ends. My brother just put these on here. So same as over there. You got your hooked as the ground. Across from it's your neutral. Here's your X and Y, which is your 2 hots. And you can see on the plug, they're labeled. X is one of your hot, Y is one of your hot, black wire, white right there. Across from it is green ground with the hook on it. So outlet, drop cord, going from the outlet, it's going to be hardwired. Outlet will go here, it'll be hardwired into the panel. You can buy these AC whips already together. It's already got the ends on it and the wire in the center. These AC whips are pretty cheap. It's called liquid tight conduit. The problem is they only have 3 wires, so you need to add in a 4th wire, which is right here. Just bought a bare ground 10 gauge wire to put in here. We'll have 4 wires, or you can buy the conduit and everything separately and buy the wire that comes with all 4, 3 conductors and a ground, and put it in there yourself. Next up, you got the circuit breaker interlock kit. Little package here, cheap. It's like less than 30 bucks, pretty easy. And then we got our breaker and just a multimeter drill bit to drill a hole in the panel for that circuit breaker interlock kit. So we got our panel right here. Just open it up, and for your circuit breaker interlock kit, it's going to go right here. And to measure for it, you just take the measurement of here and here, here and here. This is a Eaton panel, so just go on Amazon. I'm going to type in Eaton circuit breaker interlock kit, and I'm going to use my measurements that I measured for, and we're going to get the circuit breaker interlock kit, and it's going to go right here. We'll drill holes in this face, and it's going to prevent the generator breaker, which will either go here or here, depending on what kind of interlock kit you get. All the circuit breaker interlock kit does is physically prevent you from running both the generator breaker and your home at the same time. That way it doesn't backfeed into the system. So here's your circuit breaker interlock kit. Everything comes with it. You got 2 plates. One we're going to be putting on the panel, and then we got this top plate that will slide up and down like that to prevent both breakers from being on at the same time. All our caution stickers and everything, and nice instructions, shows how to do everything. We got our 2 plates. This is going to go right here, and then the spacers, and this was going to go on top of it. So when it's in the down position, you can flip your main on and off. But if you wanted to use this generator breaker, you couldn't physically turn it on because it's hitting this. You would have to turn this off. This slides up, and now this generator breaker can go either way. So we'll go ahead and mark this right here. Now we'll undo these 2 screws, take this cover off, drill these 2 holes out, and go ahead and bolt this to it. Alright, now if you want to be totally safe, you need to turn this off before you're doing electrical work. Just going to take these panels off, pull this off, just be careful. Just 2 screws on this panel here. And this panel just pulls right off. Okay, so you got your bottom piece, goes on there, screws go in from the back, just a little bit of Loctite. You're going to get your top plate, and these mushroom head spacer screws go on with the wide end up. We got a 30 amp generator, so we're using a 30 amp breaker, and the breaker is going to go right here. We're going to knock out these two spots. To use the generator breaker, I'd have to turn the main off, flip it up. The main is right here in the off position, and now this frees this up. I can turn the generator on, crank the generator. Electricity is going to backflow into the breaker and then into the panel in the house, but it's not going to backflow into the grid because your main is off. And here's your typical meter base. You got up here, it's going to come in, you got 2 legs of hot, and coming from the power system, the grid, like on the power line, they only have 3 wires. They got 2 hots and a neutral. So there's your neutral wire going over here to your bus bar, and that's where the ground, that's the communications tie-in for TV and satellite and stuff like that. There's the ground and neutral are always bonded at the panel. Newer houses are separated and they tie in neutral and ground at the panel. But we'll be clicking on our breaker right here, and then the 2 hots will go in there, and then coming from the hard wire, we got the outlet box 4 wire coming in here. We'll pop it in through here, up. The 2 hots will go into the generator breaker, and both the neutral and the ground will go on this bus bar over here. It'll terminate right here. All right, so here I got the faceplate off of the outdoor weatherproof box. Got my conduit on right there. I'm gonna put it right beside this one. You don't want to tighten this so tight that this siding can't expand. This siding can get hot and cold, and it contracts, and it needs a little bit of movement. So we're gonna put it snug, but we're not gonna like buckle it down tight. So that's that. So here's your AC whip, electrical AC whip. These ends, I'll show you how these ends work. These ends, it's called a liquid tie. All it is a cap. Unscrew the cap, and you can see that connector just slides in and out. So this is 6 foot. I don't need 6 feet of it, but I'll cut it wherever I need to when I'm ready to put the end back on. End just slides on. You got these little fingers. You can see the indentations where these little fingers grab it. Goes in there. When you slide this collar on, it's tapered and it forces all these little fingers to grab a hold of it. And it comes with 3 wires. We need to add a 4th wire into it. So I'm gonna take this end off, pull the wires out, and add in my 4th wire. Oh boy. Alright. We'll pull these wires out so we can figure out how much I need here. Stand on it. Open it up. Pull these wires out. Alright, now we got liquid tight conduit. I'm gonna see about how much I need and cut the rest of it off. Pull out our $20 Kershaw that comes from China.
It comes from China.
Conduit's hard to cut when it's cold. Alright, so we got our 90 over here. We're going to put just our straight fitting on this side. And we go into the panel, something like that. Your panel's going to have all these pre-knockouts where you can see they're most of the way cut all the way around except for little pieces of metal, and figure out which end that goes through there, which is going to be the smaller end, and size it and see which hole you need to knock out. So you got the little welded tab there. I'm just going to go directly across from this little welded tab and pop it like that right there, and then you just bend it. Comes right out, and our conduit come right up through there. Now, putting the wires back in this conduit is they're pretty stiff, and what makes it a lot easier, get you some Dawn dish soap, put your little Dawn dish soap in there and roll it around, and when you feed the wires in to this end, it lubes up the whole thing and the wires slide in so much easier. Alright, so we got our conduit on there nice and tight onto the house. Come up through here, cut off the extra, got our ends. Okay, so we got our plug here. The green is our ground. You can see the little green ground screw. And directly across from it is the one with the hook on it. So green, white, here's our 2 hots. And you probably can't see it on camera, but it's got a little W right here for the white. It's It's got a Y and an X for your 2 hots. Now this AC whip is 3 wire. We had to add our 4th wire, so I'm going to use this the thicker stranded green one as my white. So these 2 will be our 2 conductors. Each one will have 120 going to it. This will be my neutral wire, and this will be my ground wire. So this box doesn't have a ground screw on this since it's plastic. The box that I will link in the description, I think, is a metal box. So it'll have a little green pigtail coming from here and have a little screw here. You'll just run your ground coming out of here to that little ground block, and then that little pigtail will go into your ground. So we got our ground. Across from it is our white, which I'm using this one as our white neutral. Then you got 2 hots on either side of your X, Y, W for white, and then your green ground. And you can see I got a little bit extra so I can loop it around. Put it in here. Box is done. Alright, we're moving on to the main panel now. Now that we're going to be working in here, we're going to turn the power off. Now, here's our 30 amp breaker that we're going to put right here. Breakers got a little hook on this side that goes on this rail. And then you got your conductors, where the conductors go. These fins right here are the power. You got 120 here, 120 here, makes a 240 breaker. These pins just got a spring loaded clip in there, and whenever you slide it over the pin, they expand and clamp onto it. So put your hook in here and just push it, and then our 2 conductor wires are going to go in right here. So hook it into these 2 little tabs and push it. And now we got our generator breaker on. If you don't have a pair of these vice grips, they're super handy. You don't want to run, say I'm doing the ground right now, you don't want to run it straight to the ground. You want to give yourself some space in here. I'm going to curl this over and go behind my 2 mains here and over. So these go on the end. These things are super handy. We got our 4 wires. This is the 4th wire we added for our ground. We're using this one as our white neutral. This one we're using as our conductor and conductor. 120, 120, neutral, ground. So there's one of my conductors, and there's the other conductor. Alright, that one's tight. That one's tight. I'm going to tuck these wires in. Just like that. Now here's our ground and neutral. And you can see the black and the red wire are your two hots coming in from the power company. And then the white one right there at the white stripes, the neutral. The white and the ground get tied together over here at the bus bar is what we're going to do with these 2. There's my ground going in. Do the same with this one, loop it around. You don't ever want to stack 2 wires in the same hole. It could cause a little bit of resistance. It causes heat. So ideally you want to put each wire on its own separate screw. Just like that, you're done. So real quick, whenever I had this thing on there, it wouldn't slide down far enough, right? And I couldn't move the main, so I had to just take this off, and I just drilled the holes a little bit lower down, clamp it back together, no big deal. All right, we got all our wiring done. Now we're just gonna put our panel back on with our circuit breaker interlock kit on it. All right, so I had to take this back off and move these holes down a little bit, but now it's good. So can't turn this one on, and we can move this one back and forth easily. And then when we're all the way up, we can easily move this one up and down. All right, so here's all our warning stickers. Tells you how to do it. All these caution stickers, we'll go ahead and put these on the panel. And just like that, you're done. It's actually very easy. You got your outlet box, weatherproof. It's only 4 wires. And then you got your conduit. Make sure it's nice and snug on the house. Coming up in your electrical panel. It's only 4 wires. Put your circuit breaker interlock kit on it, your stickers and everything, and you're done. Now, hook up the generator drop cord into the house. Whenever you're out of power, turn your main off. It already is. Flip this up. Turn your generator breaker on. You're in business. All right, no power. And we got power. Easy as that. So I showed you a 30 amp hookup at my brother's house. This is at my house. This is a 50 amp hookup, a little bit bigger generator. I'll put a link to this cover in the description. It's really cool. Weatherproof, weighs like 9 pounds. You don't have to worry about it blowing off. Just Velcros. Sides lift up for the exhaust or whatever. But there's the box that I'll link in the description for the 30 and 50 amp hookups. It comes with whatever size drop cord you want. This is for 50 amp, 6 gauge. And goes into here. That lights up green anytime it's got power. And that's a 1-inch conduit with 6 gauge wire coming right up into the panel. Same deal. You got your circuit breaker interlock kit and all the stickers. And this is for 50 amp. You got like the stove size plug-in that goes right here. So you can see right here, this generator is neutral floating, all of them. There's your 30 amp. This is your big 50 amp stove plug, which is what I use. And this is also dual fuel, so I've got a propane line right there. Whenever I need it, I just hook the propane line to it. It's got electric start. Plug the drop cord in, bam, you got power to the whole house.